Where are y'all from?
Mechanicsville, Virginia.
You guys come in this morning?
No, we came in last week. Okay, so hi, we're 7039 Board of the Brakes. We're a small community team in Mechanicsville, Virginia. And we've had like a long journey with this robot, and we're really proud to like compete at a national level. So a big part of our robot was the engineering process. First, you have to start out with a problem or something that needs to be fixed. And once you've identified the problem, you move on to brainstorming, thinking of how to solve it, the solution. And once you think you come up with some good solutions, you then move on to the documenting it, whether it's writing it down, drawing, modeling. You do that, and once you think you've got some better ideas, or it will work, or you have a basic idea of what you want to do, you start prototyping, testing all your theories that you thought might not work, things you thought might work. Sometimes nothing will work, and you'll have to go all the way back to the original brainstorming. But once you think you found some things that will work, you then move on to creating it, which is where you finalize the product. And again, nothing might work, and you might have to return back to brainstorming. But if you find something that works, you improve upon it, and then you finish it, you start over again. You go back to finding a problem, and brainstorming, documenting, prototyping, creating, improving, and then you start over again, and that's the engineering cycle. Thank you. So with using that, we originally wanted a robot that would push blocks and it would turn the flag consistently. And the next competition, we had added this autonomous arm, you can see right here, and we would get like that 40 points with the IR sensor. We have the IR sensor as well. And then we wanted to be able to pick up blocks. We had to make a minor issue, so yeah, this is the yeah.
Is small and maneuverable, and also uses less power. We have received power feeds. Connections give us we have foam rubber to reduce static between our Samantha and our motor controllers. We have a short USB cable between the NXT and the Samantha to reduce electrical use.
So there was a lot of evolution that went into the arm. Nicholas, would you like to speak about that?
With the arm design, we went back to the engineering design process by first asking what exactly we needed to do, which was to pick up the blocks and put them in the basket. So then we started thinking of ideas like floppy thing, egg beater-like contraption, and a scoop. So we built prototypes of each one, as you can see in those pictures, and tried to find out which ones would be the most efficient to pick up the blocks. And we first tried the egg beater one, but that ended up burning out our motor because we couldn't control how it clamped on the block. So we went to a scoop because that's a lot easier to control. And we had to brainstorm how we were going to do the scoop, what it was going to be made of, how we were going to attach it to the arm, and we also that we ended up on an aluminum scoop that we had to take off to fix. And with the vertical raising of the arm, we had originally started out with a Tetrix slider rack and pinion set that, it caused too much friction with the gears and track that it had to roll up, and it also caught several times on its way up. So we tried drawer sliders, but we couldn't figure out how to use the pulleys to lift it, and we ended up going to IGUS sliders. We ran into the same problem with the drawer sliders, that we couldn't figure out where the string to raise it. So we ended up using this this arm that is attached on one point with a 3-to-1 gear ratio to increase the torque to pick up the blocks, and this servo-mounted scoop on the end with 3 positions to level, dump, pick up, dump, and level out the scoop.
Thank you. So, another aspect was as, I don't currently have a but in my autonomous, I have the robot run parallel to the baskets, with the baskets on the left side, I intended to have it run on both sides, but one side wasn't working out because the pillar was blocking. So what it does is it runs parallel to the basket, and then when it finds it, it turns left to face the basket and dumps the block using this IR arm, or autonomous arm. It then turns back towards its starting point, drives near to where it started, and then turns using a timer. It comes back so that it wouldn't hit the wall, but it would. And then it turns perpendicular to the ramp. After driving forward a bit, it turns away from the ramp, backs onto it because our front wheels are too small. In Teleop, I use, for the second controller, which controlled the arm servo, I use these 4 control buttons to control the servo. Up, down, and middle. And then this was another one of these because this one has at one time. And the bumpers control this motor, up and down. And on the first controller, it controls the drivetrain and the flag turner, along with an emergency button for the autonomous arm, in case we don't score it in autonomous. These control the autonomous arm, up and down. These 2 buttons control the flags. This one moves slower to position the arm, and this moves quickly to raise it. And the joysticks.
Another aspect of our team was CAD, because the CAD informs an organized build. So here's the CAD of our chassis, as there was a lot of parts that changed as we thought of new ideas. So here's the basic idea for right now, and here's an idea I had with the 3D printed scoop. So, let's see.
What software did you use to?
SolidWorks 2013. An aspect of outreach was the Promote Award, because we presented it on YouTube. Abby, would you like to speak to that?
I was asked to do the Promote Award video for the team. It's originally actually how I joined the team, so I was asked to do it, and it's been a lot of fun being on the team. So first, I was inspired to do the video. My idea for the video was inspired by an article I read that was shown to me by a team member about the myths of engineering, which were things like engineering is boring, it's hard, things like that. Just make it a lot of stereotypes and myths, as that's not very interesting or fun. So that's what I was inspired by, was all these myths. So I had to script it for 60 seconds, since the video needed to be 1 minute exactly. So I scripted it all out. I had to get rid of a large portion of what I wanted to do because I wasn't able to fit all the information into the Then I moved on to storyboarding once I had my script figured out where I wanted everything to be at what points in the scripts. And then I had to record the voice so I could line all the drawings and things up with the audio. And once I was finished with that, I went back, I referred to the storyboarding to start drawing all of my images using Paint to Say on a pen tablet. So there were pictures to go along with the audio. And then I went over to Vegas Movie Studio and put in all my pictures at the right places corresponding to the audio. And I actually drew 3 frames per picture, so it would be a little bit animated, so it wouldn't just be a plain picture. And so I did the video.
So a big aspect that First Rec respects is the Connect Award, where you connect with the community and connect with engineers. So as you can see, there's been a lot of outreach. Oh, sure. Yeah, we can move the robot.
This is all this year.
We had some more, just we couldn't fit on the board. So, yeah, it's in the book. But, this was inspired by the first game that I attended. So, the outreach, a big outreach was Kai is a volunteer at the Science Museum, and he's done it for 190 hours as gallery education. So he just explains the science behind each exhibit. I was invited to speak at the State Department for, on behalf of the Global Partnership Initiative for Diplomacy, where they're making programming centers for underdeveloped countries. So I spoke about how programming it couples with mechanical know-how, so you can make an impact. So I spoke with the Tanzanian ambassador. She just got a programming center in her country. I spoke with the British